Hello, everyone. I hope everyone enjoyed the session today. And I know the timing is a little bit difficult, so welcome to the afternoon session. Now, in this session, I have a few of my colleagues here, and we're going to talk about how do we unlock the new energy potential to power this great country. Now, we want to make sure that we power the country with the best, safety, reliability, and sustainability. So let's get things started. Okay. Whoa. Yeah. Wow. So I hope in the real world this never happens. So what you experience is actually a simulated blackout. But imagine this is happening in a major event like this, but even worse, if this happens with a mission critical facility like hospitals, even like data centers, right? That will be not just an inconvenience, it's going to be a catastrophic situation. So life is on, power is back. We always assume that electricity is always there, it's a magic, but actually in many parts of the world, it's not like that. You could have a meeting like this and the power can, flicker. So welcome back again. My name is Bing Lu. I'm the EVP for Power Products Division at Schneider Electric. We're responsible for basically the whole lineup of the low voltage electrical products. Together with me, I have three esteemed guests coming from different ecosystem companies, and we work very, very closely. So we're going to share the stage for the next 35 minutes, and hopefully we have some time that we can keep for Q&A at the end. So I'll let my colleagues here to introduce themselves.
Thank you, Ben. Thank you. Good afternoon, everybody. My name is Yui Tu, Vantage Data Centers. I lead our energy innovation, sustainability.
Good afternoon, everyone. I'm Brian Melka. I'm the CEO of Relco. And at Relco, we provide base load and backup power for any mission critical situation, hospitals, wastewater treatment plants, utilities, telecom, and of course, data centers.
Hello, everyone. My name is Jeff Smith, and I'm with UL Solutions, which together with our family of companies, UL Research Institutes and UL Standards and Engagement, we're involved in helping to set standards for fire and electrical safety and other characteristics, and then also to test and certify equipment against those standards. Thank you.
Thank you, and welcome to the session. And welcome all of you to join the session. So like I said, this session, we're going to talk about how do we make sure that we power America, okay, in terms of different applications, data centers, buildings, utilities, and so on. And you heard it from our CEO, Olivia, this morning talking about we as a company, right, our vision, mission is energy tech company. We electrify, we automate, we digitize to make sure that we support your growth for all of the industries, homes and data centers and so on. And we want to make sure that we drive the efficiency and the sustainability for all. Now with that, we want to do a quick recap of what you heard this morning. And actually a few of us, we were in the NEMA conference just last week. Everybody's talking about how hungry the power grid is, okay? From an electricity perspective, okay, the percentage of the electricity as a portion of the whole energy is going from 20% to almost 50% from 2020 to 2050. That's number one. And the second is, everybody's talking about AI and data center, right? The new generation compute devices being introduced to the market very, very quickly. We also need to make sure we power the data center. A data center, as one example, the percentage of the electricity used is going from 3% to more than 10%, even 12%. If you pay attention to what our North American President Amar Paul said this morning, in part of this country, like Virginia, the percentage of electricity used by data center is not 12%, it's 39%.
39, yeah.
Yeah, exactly, 39%. Just imagine, okay? And that number is growing very, very quickly in the next few years. So I'm sure that all of you and many of you, your customers, your partners are worried about how do we get access to power? How do we get access to electricity? So the number you saw on the stage there was basically a recent study done by EY, right? They say 66% of the companies in various industries are really starting to get worried about this access to power challenge. Now, you also heard that my colleague, actually my boss, Fred, talking about the power system, the utility is really changing, The power system has been there for more than 100 years. It's largely a linear system. You go from generation to distribution to consumption, okay? Now, Schneider Electric, with our partners, we've been in this business for a long, long time. But as you see, okay, every single day, the grid is evolving. Okay, the grid is no longer a linear network. It's becoming a bi-directional network. As I mentioned, right, you see different kind of applications or segments, data centers, and so on and so forth. But at the same time, the dynamics is changing. Okay, you have more renewables, more wind and solar. Because renewables, it's hard to control. You cannot call the sun to come, right? You cannot call the wind to come. So you have to make sure you address the challenge of consumption and generation, and they're not always synchronized. You see the curve today, right? You start to see a lot of discussion on energy storage, battery energy storage systems, BESS, okay? So for us as a company, we really look at the grid as a changing, evolving system. The word system is very, very important. So now, the second part of the discussion we will have there is, so beyond just getting that power to power the data centers, all different kind of applications, how do we get that electricity from the grid into the chip? You saw the rack this morning, right? My colleague Pankaj was talking about that. That rack power density is going from 30 to 50 kilowatts to 1 megawatt in literally 3 to 4 years. And this is where NVIDIA has published this 800-volt DC architecture, and they're working with all the industry partners like us to make sure we're ready to support. So how do we make sure we power the chip, get that electricity into the system? So you will see that the system architecture is really starting to evolve, not only the traditional AC-based, more and more hybrid and direct current-based. We'll talk about that. So with that, it's really a new energy landscape. It takes an ecosystem of partners working together. It takes a village to prepare the industry for the future. Now, with that, I'm going to ask questions to my fellow panelists. So, first question, right? We talk about the data center being the most hungry segment, right? There's a tons of electricity you need. So, Yue, you guys are in the center of this data center business. Mm-hmm. So how do you see the challenge and how you guys are working with industry partners to address the challenge of the access to power?
Absolutely, yeah. And thank you for the opportunity to share my perspectives on this. And I'll break it down into kind of 3 pieces. Number 1, we'll talk about what I see as the evolution, what's changed. And there's probably 3 big changes that I've seen, right? We've gone from a world of megawatts to gigawatts. Some people call it a gigawatt, right? This is all predicted in 1985, Back to the Future, right? 1.21 gigawatts. Luckily, we don't have to steal plutonium or rely on a lightning bolt to create that amount of power. But certainly the world has changed dramatically in just a couple of years from a megawatt world to a gigawatt world. So I think that's very, very significant. The second thing that I see that's changed is anybody here obsessed with uptime? 99.999%, 5 nines, right? I was certainly one of those folks who, when you had the blackout, I was like, I'm thinking, oh my goodness, UPS, diesel gens, gotta be ready, gotta be ready for this blackout. So luckily, I think I was counting, it was only about 7 seconds. So it doesn't count for any safety metrics for those in the utility business, doesn't count towards that. But we're going from an uptime world to a world of continuity. And this is former colleague of mine, Paul Trinock, talks about this, right? It's really rather focusing on obsession of how long the lights are on. It's really about the continuous process of the system of AI thinking through its process, right? Making sure there's no disruptions in that thinking process in order to get all the training steps done. So I think it's a big evolution from an uptime world to, I think, really a much more smaller increment of unit of time. And then the third big thing that I've seen, I think is a very positive evolution, is going from an effective effectiveness metric of PUE to now focusing on tokens per watt per dollar, which we also heard this morning. I think that's a very positive evolution in terms of really measuring, I think, what matters today in terms of AI computing. Now, there's a lot of things that have also remained the same, and I think that adds to the challenge. So, for example, speed. I mean, speed has not changed. Like, we've got to be able to deliver within, let's call it a 24-month time period from a piece of dirt to ready for service for our tenants to be able to move in. That 24-month period has not really changed. We still have to solve for all of the above in that kind of time period. So that's number one. Number two, we still got to do it at a cost that is, that makes sense for our customers, that pencils out commercially for ourselves as well as our tenants. That's going to really key thing, hasn't changed. And the third thing is sustainability. I mean, we've got to be able to do this in order to get, obviously, the growth of our business to be able to be growing at a sustainable pace, as well as be able to get the buy-in of stakeholders, not just our customers and community leaders, right? All of the above. So I think the sustainability is all, very important. When I joined this industry 10 years ago, my manager, Brian Janis, said, there's three things you got to worry about: capacity, cost, and sustainability, right? It hasn't changed. These three things have not changed. And what's great about Vantage in this last year is we're doing it. We're building, these gigawatt scale facilities, and we're able to solve for the speed. We're able to solve for, the costs as well as the sustainability. I'll just use one example, right? In our Wisconsin, in your hometown, we've got in Port Washington, a data center that we're working with We Energy, so the utility provider in Wisconsin. We've got a capacity stack that's got over almost 2 gigawatts of clean, carbon-free, zero emission capacity that's in that stack, and to enable the growth of our data center in Port Washington. So that's just kind of give you one example of how we're being able to do this still while maintaining the speed and the timelines. So, in the later session, I'll talk a little bit about the how and how we've been able to do this, but I'll turn it back to you.
Yeah, I resonate every word you said. Actually, for a few years, I was running the data center business in Schneider Electric right around the COVID time without traveling, and try to manage this huge growth of data center business was amazing. So actually the speed, right? The speed. And now you see the speed is not getting slow, it's getting much faster. And the power, we used to talk about like 3 megawatt, 5 megawatt power data center as a big one. Today, come on, right? You're talking about a 50 megawatt, even gigawatt data center. So tons of power there. And also we want to make sure that we make sure it's reliable, right? It's safe. Now talking about the reliability, the expert is sitting right here. So Brian, you guys, Relco, you're really a leading company in the space talking about resiliency, right? Reliability for the power. So what do you see in your company in the ever-changing landscape?
Yeah, it's really interesting, and I'll tie into a couple of these gentlemen have already shared. If you look at the way power has been created and distributed, this linear fashion that's been talked about, it goes back 135 years, and really nothing has changed. Yes, we've added some nodes to it, but if you look at the traditional power creation and distribution model, it hasn't really changed in 135 years, and it's just starting to change now. But the thing we hear about most consistently over and over again, besides reliability, is speed. And you talked about that. The ability to bring speed to power. The number one question we get more often than not is, how fast can you get it? How fast can you get it? And when you look at the old model of power creation and distribution, it was not built for speed. It was built for scalability. It was built for size. It was built for just creating a lot of power, which was then distributed, but it was never built for speed. And frankly, to solve the problems that we're facing now and going forward, that model is just not going to work. We don't believe that model is going to work. A lot more of the model of the future is going to be about on-site power generation and management. The ability to build your own baseload power behind the meter or grid interactive through different technologies, internal combustion engine technology, but also renewables. But that need to get there quickly within 24 months is not going to be solved in the old model. You have to build reliable power on site. You have to build the reliability, the resiliency of that on site. And the speed to power is driving kind of two components of that. One is on-site power generation or behind the meter. The other is modularity, or the ability to build kind of modules of power that can be scalable. Because while you may have 2 gigawatts on site, it's not all going to come online on power at once, right? You're going to build that over time. So how do you not build 2 gigawatts of capacity, but how do you build that capacity such that ultimately I get there, but in a modular approach that I can build 50 or 100 megawatts at a time? So speed drives on-site power generation, also drives modularity to be able to scale that up over time.
Absolutely. Speed and cost, the modularity, technology plays a very, very big role. Now, my next question is actually going to go to my new best friend, Jeff. It's amazing. I've been with him the last 3 weeks, like 3 times. I'm joking, like, see him more than my wife these days. We were together in the NEMA conference. We were talking about, again, the same topic with very different audience. So, really the question is, you guys, your solutions play an absolutely critical role to rally the whole industry together so that when we solve this speed equation, right, and also the power equation, we manage reliability, the safety, right, eventually sustainability. So tell us your experience here, your role in this ever-changing world.
Yeah, thanks, Ben. And it's been great to get to know you these last few weeks. Look forward to continuing that. So I was so glad this morning that, the presenters were very clear about the need for speed and safety to go hand in hand. I think we all understand that, but we need to keep saying it out loud. I have a phrase that I often borrow from someone, which is that standards create markets. When standards are all agreed to, markets can scale quickly. Before that happens, though, they can be seen as an impediment. And I think right now, the reason why people are so interested in talking with UL is because we do have that role to play. We have to bring all the stakeholders together, and we need to do it faster than ever, right? Now, I like to remind ourselves, we're bringing together, call it the white space and the gray space, call it the IT industry with, the more traditional industrial infrastructure industries. The IT industry had the benefit of Moore's Law, which held up pretty well through about the 2010s. And what that meant for the IT industry is they could scale more and more computing power without having to increase the power requirements. And on the power side, we have another law. It's called Ohm's Law, and it doesn't scale quite the same way. And so I think and maybe we'll get a little deeper into this, but we're reconciling with very real engineering challenges to meet the kind of, dare I say, almost insatiable power requirements for data centers, which societally, from a human perspective, everybody's excited. It's the next big thing. We just have to be sure that as we go through this, we do it safely. So one example, we talked this morning about DC and transitioning from AC to DC, and that's all about practicality. You can't bring the level of power that these data centers need from an AC perspective. You have issues with the size of the equipment, you have issues with heat management. So DC solves a lot of those problems, but it introduces new challenges that need to be managed, particularly around DC arcing. And I'm not talking about arc flash, which can cause worker safety issues. That's very important. But even, DC is a continuous load, and it can arc for a long time and lead to catastrophic events where there are no people around to see it. So, our commitment as UL Solutions, and the reason why I'm here on the stage and very happy to be working with my colleagues, is we get it. We need to move fast. We need to get standards. Before standards, we need to have draft requirements. And most importantly, we need to work with industry to get enough consensus around them that we can continue to build at pace without sacrificing safety.
Yeah, great. Actually, this is probably the reason why we're spending so much time together, right? Because I reminded the team this morning on the stage, my colleague Pankaj Sharma talking about the AI factory / data center, right? You have this rack in the middle of the stage, right? It's going from 120 kW. It's actually, the old ones is actually even less than 50 kW, right? It's going to a megawatt. A megawatt powers a lot of phones, a lot of power. So how do you get the electricity from the grid or the microgrid into that system, eventually to power the chips? Okay, it's a huge challenge. It's a huge engineering challenge. Also, if you do this right, you're able to manage the cost equation. Otherwise, that cable or busway becomes that thick, seriously, right? Now, Jeff also mentioned about this AC DC direct current architecture. That's actually my favorite topic, because when you look at a future data center, right, it's not just it's getting more power. The architecture of the data center is fundamentally evolving. It's driven by the law, okay, the new law. It's not the Moore's law, it's the Jensen's law. Okay, Jensen Huang's law, where every few months they introduce a new compute device, okay? The compute device is going to give you much more compute capability, but at the same time, it requires more power. So it's becoming power hungry, okay? So as you see the new generation of the compute devices being launched, and you start to see, the question becomes, how does the rest of the industry find a way to power that chip eventually, okay? And also to take the heat out. So it's becoming grid to chip and taking the heat from the chip to the chiller, right? So this is where, like Schneider, we work with our industry partners to really address that challenge, okay? So now talking about the evolution of the architecture, first started with the system, and then you look at the system is changing. So today's data center is still largely AC, okay, alternating current. But you hear the industry is talking a lot these days about 800 volt DC, 800 volt direct current architecture for data center. Now I remind you, data center is not the only thing in the world. We love it, you love it, I personally feel very proud, but this electrification driving this AC to DC, evolution on architecture is happening in other applications like buildings, okay? Like charging stations, okay? So now, let's spend the next, I would say, 15 minutes talking about this great evolution of architecture. Let's pick data center as best example, because this is happening right in front of our eyes. And actually, because we're here in this great country in the US, the speed of this adoption to the new AC-DC architecture, new direct current architecture is really being led by the data center industry. So again, my question to my colleague here, how do you see this is changing how you guys build data centers, right? Again, with the speed, with the changing architecture, what kind of new challenge that you see, and how you guys are ready to solve the challenge?
Right, yeah. I mean, the challenge is speed, right? Everyone's got to follow what's happening with how the chips are being designed, the densities there. I'm happy that there's a lot more things being published now, so that everyone has a chance to kind of review and read and be able to kind of collaborate. That is one of the areas that I think we've leaned in more recently as a connector, right? We don't have all the answers. We have a space that we do really well, right? Which is build, operate our data center. But we want to make sure that our data center is going to be home to the latest and greatest chips that are available. So we need to work with our partners very closely. We need to kind of think about the full value chain of our business from grid to chip. And the way that I've been thinking about and explaining to folks in our organization is kind of break it into three chunks. There's the on-grid part of the energy value chain. There's the on-site part of the on-site of the data center site. And then there's the on-chip part. And all three of these kind of main arenas, there are main players, there are key players who are incumbents. There are also startups out there who are coming up with new solutions. Got to be working across this value chain to be able to solve for it. We're not going to be able to solve for everything ourselves, right? We definitely recognize that limitation. And I think part of this challenge is knowing which fight to fight and which fight to really make sure that we bring in the right allies and the right partners to be able to solve this problem. Obviously, density is the name of the game right now. Power density, as you just mentioned, 1 megawatt rack, very difficult to wrap my brain around. But that's the future. That's where we were headed, and certainly a DC, a direct current environment, an architecture environment, would enable for much greater power density. It's certainly one of the main pathways to a higher density solution. And so when we think about that, right, that's what's happening inside of our facility, inside of in our space, in our gray space, and of course that's going to be changing the white space environment as well. We also have to be keeping in mind, how does this impact our our utility partners or our on-site generation power providers, right? Because every gigawatt that you bring into your data center, you've got to figure out how to distribute it ultimately to the chip. And I think that's one of the great challenges that we've got to do. But I think being able to unpack it, be able to collaborate on these roadmaps, which is why being able to talk about them, publishing white papers, being able to put something on the table for multiple parties to be able to tackle is part of the solution in solving this very quickly. And I think I'm very happy that we've got this relationship, and as part of this sort of consortium to try to solve for this at the bleeding edge of kind of this next generation data center, next generation AI factory.
Absolutely. Now, actually, I resonate the word you said, connector.
Mm-hmm.
Okay.
Yep.
Actually, if I look at all the companies, there's one company that is really connecting with almost everybody. That's actually my friend sitting there, Jeff. You guys, UL Solutions, you work with really a lot of different companies, various industries. Now, if you look at this challenge we talk about for data center, there's density issue challenge we have to address. And there's the access to the power we have to address. There's also sustainability angle we have to make sure, we have a future for the planet and for human, and also the safety, okay? So, want to hear your perspective in these all the aspects. How do you guys, from your perspective, help the companies to address this multidimensional challenge?
Yeah, thanks. I think, Brian has touched on the need for basically generating power local to the facilities and taking a lot of that burden off the grid. I mean, we know the grid, we heard about it this morning, it's going to have to evolve. But I wanted to start there. Because the topology of electricity has changed so much, a lot of the expectation requirement around safety, reliability, interoperability, if you look at distributed energy resources or inverter-based resources, the inverters have become incredibly sophisticated components sitting in the middle of the grid. And, the UL standards have been a big part of driving with industry how all that works. Coming back to your point around sustainability, so for the last 15 years, we've been writing new standards to support things like solar, wind, energy storage, electric vehicle infrastructure. But this data center thing, just for all of us, kind of came out of nowhere. It was like we were trying to make the grid more sustainable, trying to facilitate new technologies in a safe way. Because as you mentioned before, DC at higher voltages is showing up in a lot of these applications. Now it feels like people aren't really talking about sustainability as much, but I do want to just quickly comment on our partnership with Schneider Electric in this vein. First, UL was invited to be a founding member of Current OS. Current OS is a kind of a foundation that's coming together of interested parties to develop DC requirements, and it was initially more around sustainability, sustainable buildings, and how we could deploy DC technology to reduce transmission losses, conversion losses, et cetera. We're now, though, fusing it into data centers and saying, how can we bring these two worlds together? But I really want to applaud Schneider Electric's leadership in driving sustainability. And I know more recently, and we're going to talk more about this in other sessions today, we're announcing the first Eco-Logo certification of a molded case circuit breaker for Schneider Electric, which really you came to us and said, hey, just because we're making infrastructure and people aren't buying it, retailers aren't buying, or consumers aren't buying it off retail shelves, that doesn't mean sustainability is unimportant. We need to also look at the sustainability impact of our products and our whole life cycle. So we're very pleased to be able to work with you in that. We see security, sustainability, and safety as all fitting together, and the requirements around that becoming more and more sophisticated in the next 5 to 10 years.
Yeah. So Jeff, actually, thank you for bringing it up. And we have actually a leading event for this industry first Eco-Logo product certified by UL Solutions to be safe, but also very sustainable, from design to use and all the way to the end of the life. We're going to sell these breakers to all of you guys, right? So, so this is actually a very good example of how the industry work together, form a partnership and solve this multidimensional challenge. So I want to use the next few minutes to talk about really a partnership. Okay, partnership. Now you heard loud and clear today from our CEO and our leaders we really put the partnership in the center of our mission, because we want to be your energy tech partnerships. And one thing that differentiates Schneider Electric with many companies, partnership is at the DNA of the company. We're very proud we have the industry's largest partner network. We have 1 million partners globally, okay? So when we look at a challenge like this, we believe it's not something that one single company can address alone. It takes a whole village to work together, okay? Our end users, partners, suppliers, policymakers, standard committees to work together to address the problem. So now here, I'm going to give the question to Brian. I mean, you've been in the industry for many, many years, very seasoned. What's your advice to all the leaders here? How do we work together to form the ecosystem of the partnership to really address this problem in front of us?
Yeah, it's a great question. I think seasoned means old, by the way. Sure about that. It's interesting. I want to just kind of triangulate this a little bit in that Ben mentioned earlier that, data centers today, and I'll use that as kind of an example, they consume less than 5% of the power in the world. And there's certainly examples of more. But if nothing changes in the next 5 years, they'll actually consume not 10 or 12, they'll consume 25%, right? Because we have to bring a lot more capacity online, while we also have an aging infrastructure. That 100-plus-year-old infrastructure we talked about, 60 to 70% of it has to be replaced in the next 2 decades. So you have this environment where you have this massive demand scenario. By the way, data centers are not the only ones demanding more power. Homes are demanding more power. Businesses are demanding more power. The grid is getting less reliable. More backup power is needed. And today, the way to solve that is largely, individuals or individual companies like data center operators are taking it into their own hands to solve the problem. I was with a data center leadership group a couple months ago, and one of the things I told them is I said, if you don't solve your energy problems, no one else is going to solve it for you. Like, you don't have a choice. You have to solve it. And today, the way that's being done is very compartmentalized, but it's starting to coalesce around compliance and regulatory, end users, connecting partners like Schneider and with us to really look at how do we optimize the system of the future. And data centers, we keep coming back to that because there's such a large part of the growth in energy consumption that's going to happen over the next 5 years, 10 years, 20 years. I don't know exactly, but it's going to be the single biggest driver of energy demand growth. That's where we need to solve it, because I think that is what's going to ultimately transform the entire energy landscape, the entire energy industry. But it only happens when the users, the operators of the data centers and builders, the connected, providers like Schneider, the component or the large kind of power generation manufacturers like us come together with the standards environments to create a cohesive system to deliver that. Because if we don't, it's just going to end up a sub-optimized, solution that's going to get Band-Aid approached because somebody needs power now. And they're going to deliver power now, but it's not going to be the optimal solution unless we come together and solve it as one group. And I don't have a lot of confidence in the utility providers being able to do it either. So it's not that they're out of the solution, they have to be part of it, but industry has to solve this problem. And we have to do it with our partners. Otherwise, it's going to be suboptimal.
Absolutely. Actually, this event, we had the pleasure to welcome all of you. We have more than 2,000 companies coming us, really from all aspects of the ecosystem. So now the same question, I want to leave at least a few minutes for Q&A. Any last advice, last message from Yuan and from Jeff on this ecosystem partnership?
Yeah.
Good, please.
I mean, I'd love to maybe kind of just continue that thread that Brian was talking about. I think if from the start of the data center industry, we've always been very dependent on the grid, and when we need electricity, we just go to the utility provider and said, please provide me X utility by X date, right?
How's that working now?
And now, in the present moment, there are spots where we're having some challenges, some really difficult challenges where there are delays, but there's still some places where we're able to get interconnected, like in Wisconsin, for example. And so I think there is where I see kind of the future headed is the data center operator does need to play a much more active role in the grid, transforming that data center, which traditionally has been a load center, into a two-way, relationship with the grid, being responsive to the grid, potentially provide services to the grid. Obviously, there's a revenue stream there, but I think there's also a clear value proposition in ordering to, as a return of being able to have an asset that can be responsive to the grid, utility grid. The utility would be more than happy to interconnect the data center, right? The challenges of the grid, as we know, is a few handful of hours in year 7 or year 10 when they're doing a forecast, when they're doing a planning cycle. And so if we can help solve for some of those hotspot hours, you've got an opportunity to have a much more optimal configuration for your data center with some type of flexible resource, which could potentially be enabled by Schneider's architectural product lines to be able to have that two-way conversation. It seems like we've been talking about this idea of the prosumer for far too long. And I think now with the moment that we're in, with the crisis that we're dealing with in terms of the delays and the challenges on the grid, I think there's a much greater opportunity and a value proposition, a commercial value proposition that could allow the data center to be able to play a much more active role, spend essentially a little bit more capital to be able to do that, but be able to get interconnected and potentially also take advantage of some of the value streams, the revenue streams that provides.
Absolutely. Jeff, any final comments?
Yeah, I mean, I love the emphasis in this summit around partnership. And, in my experience, the evidence of a really strong partnership, whether it's, in your personal life or in a work environment, is the ability to get to the right questions and have the right discussion as quickly as possible with as little drama as possible. I'm not saying that's easy, but that's the sign of a really great partnership. And I don't want to sugarcoat this. There is a tremendous amount of very real technical challenges that need to be worked through by industry. But I'm so glad that America is leading the way. Actually, our whole approach to developing codes and standards and testing and certification, it's pretty much all driven by the private sector in this area for a whole lot of reasons that I won't bore you with right now, but I've been with the company 24 years. I've really studied this to understand why that is. And I think that, one of my favorite quotes was from Winston Churchill when he said, the worst possible form of government is democracy, except for all the alternatives. And in many ways, going through the process that's really hard work of laying out codes and standards, doing, you still got to do projects, right? So we got to be flexible to say, how do we see where the real issue is, bring the right people to the conversation, make it good enough so we can continue to progress, learn from what we learned, consolidate, and continue to progress. That's our commitment as UL, and that's really what we look for in partnership.
Absolutely. So now we'll wrap up here. So we bring the industry here together for these 2 amazing days. I hope you enjoy. For Schneider, we look at this as an energy challenge, okay? Schneider, we operate globally. This is the largest market we have. And actually for US, we have a particular challenge on the energy part. Okay, it's actually not an energy transition problem, it's energy access, energy expansion challenge in front of us. We believe there's digitalization happening, there's electrification trend happening in front of us, and we believe technology. We believe that we have most of the technology ready to address the majority of the challenges together today. But it really requires the whole village to work together. So for us, technology is absolutely important. And the second, partnerships. Partnership is really at the center of our company's vision and mission. So we really appreciate that all of you come here, and thank you for my panel speakers to join us. And we have about 4 minutes. We can probably do 1 or 2 questions. So the floor is yours. Any question?
One brave soul.
Yes, please.
I wanted to give others an opportunity, but really great talk, folks. Thank you so much. If I take a step back and think about this problem as not a member of this industry, one of the things that we're seeing is electricity rates have gone up for consumers in quite a few markets in the industry. And now if I think about the message of partnership, right, we're talking about all of the organizations coming together. We're also talking about government playing a role. What is your view on policies policymakers, policy, and also how consumers see where this industry is going forward?
I have a very strong opinion on this one. I think, one of the things you see is that there's some underlying kind of inflationary causes for electrical costs going up. But one of the biggest drivers is that current retail customers typically have to pre-fund all the capital required to build out the new infrastructure, which is why I so strongly believe we need to open up from a regulatory environment a greater ability for people to be independent power producers. Get a lot more behind the power. The biggest consumers of this are data centers. Let them generate their own electricity. Let them become an independent power producer. Don't put the capital expenditure, the pre-funded capital expenditure that's going to take 3, 4, 5 years to build out. Don't put that on the retail consumer. Put it on the consumers of the electricity, which they may not love, but at the end of the day, they need the power. And the biggest driver of that is they have to pre-fund the capital. Put it on those that are actually going to use the power and allow many more people to become independent power producers. That's the biggest regulatory change that we could have that would take the burden of that cost away from the typical retail consumer and put it on the ones that are ultimately going to use the power.
Yeah. I largely agree with that. In terms of the cost, we've got to obviously be able to bear the cost that we are, creating in the grid. And I think that is part of the kind of the new tariff designs that we've, been working with specific utilities to create a tariff that is just for us, that we ring fence all the other ratepayers, other users that are in the network. We figure out what are the total capital costs. We'd be able to essentially underwrite those capital costs in order to, make sure that others are not affected. So I think that that's from a principal perspective, that is, there's no debate there.
Yeah.
I do.
How you do it is there's different ways to do it, but
right. Yep.
If I may add one more thing, this is also a call for action for all the industry leaders to bring the voice together. And as a matter of fact, Jeff and I were in the same meeting a couple of weeks ago in the NEMA and DOE, right, earlier, to really talk about how do we solve this from testing and certification and everything. Because eventually you look at this, the challenge is the speed. Okay, the speed of this ever-changing challenge, the power and everything, and also the speed for everything policy, standard code, it is not at the right proportion right now. So we really need to make sure we bring that voice together, okay? We have time for one more question. Any other question?
Kieran.
Thank you. Great panel. Appreciate everything that you guys have shared today. You mentioned speed to power connection. You're having great success in Wisconsin. Are there other parts of the country where you're seeing that same success?
I can't talk about the other projects that we've got going on right now, but there are definitely locations in the country where utilities are looking around and wondering how come none of the data centers are coming to our region, right? So.
I do think the federal mandate to have these decisions made in 60 days is a driver of trying to open up that interconnect. We'll see how well that sticks, but I do think that's a big push to say, don't drag these decisions out for months or years. Make the decisions faster, one way or the other, but it's going to allow that hopefully to speed up in the local environments.
So with that, thank you very much for your attending to this event.